So, welcome back to the Web3 Insights, where we break down the protocols and pioneers that are shaping the decentralized web. Today's guest is Grigore Rosu, who is the president and CEO of Pi Squared and the inventor of the K framework. We're going to be diving deep on the technical challenges and real-world solutions that Pi Squared is building to unify fragmented blockchain infrastructure and simply simplify the developer experience. So let's get straight into it. Grigore, thank you so much for coming on.
Thank you for having me.
No, absolute pleasures. Grigore, for listeners who might not be familiar with your work, could you give us a quick intro into your background and what brought you to Web3?
Well, I started with my PhD, which I did at University of California, San Diego, and I developed languages and frameworks for programming languages. Then I worked at NASA for 2 years, applying what I did during my PhD to mission-critical software, where the idea was to design systems correct by construction and also catch errors very early when they are cheap to fix. Then I moved to the University of Illinois, Urbana-Champaign, as a professor in 2002. In 2010, I started my first company, Runtime Verification, which is now a security auditor, a major security auditor in Web3, basically trying to find errors in people's software and smart contracts and protocols and everything Web3. And then in 2024, 1 year and a little bit ago, I started my second company, Pi Squared, whose aim is to do everything correct by construction. So without errors by design.
Awesome. So you invented K framework in 2003.
Yes.
What exactly is K and what inspired its creation? Also, as well, within that, how does it relate to the challenges that we're seeing now in blockchain?
Yeah, so the idea came when I worked at NASA as a research scientist, and I saw my colleagues there, extremely talented people, reinventing the wheel over and over and over again for each new programming language. And I said that this cannot be right. We need a framework, a language framework, in which a programming language or a virtual machine language, any language that computers understand, should be defined once and for all. And then have a menu of buttons that you can push in order to generate, correctly by construction, the tool that you want for that language. Be that an interpreter or a compiler or a formal verification tool or a model checker. So instead of implementing these tools separately for each programming language, which requires a lot of effort, it is at best uneconomical, but also it wastes a lot of talent. We want to have a framework where you define a language once and for all, and then you get all the tools correct by construction automatically from the definition of the programming language.
Amazing. And let's get into Pi Squared then. How does Pi Squared aim to solve fragmentation and trust limitations in blockchain infrastructure?
So in two different ways. So first, it brings together all programming languages because of the K framework, which is a meta language, which is a framework, a language of languages. All programming languages now are like programs in some sense in the K framework. So programs in programming languages now are just inputs to one program in some sense on the K framework. So all programming languages now can live together the same way, metaphorically speaking, like all mathematical theorems live in the same world of mathematics. So the same way all programming languages live in the same universe. So it doesn't matter what programming language you prefer as a developer, because you can now interoperate and you can interact with any other programming language uniformly. And two, everything happens correctly. You don't have to worry about errors in compilers, errors in interpreters, errors everywhere, right? Because everything now goes through mathematics.
Yeah. What are the core the core design principles behind Pi-squared's architecture? How do they differ from, let's say, traditional layer 1, layer 2 blockchain frameworks?
So in pi squared, the basic unit of reasoning is a claim. A claim is something that comes with a verifiable proof, with something that is true. So everything you want to claim, for example, that you are Aaron, it comes with a proof. And if that proof is verifiable, now that claim is settled once and for all. So it differs fundamentally from blockchains because there is no chain and no blocks either. It's just all these claims, they live together in one set. Actually, that's how we call the new structure, set, S-E-T, from settlement, but also because it's a set of claims, all of them with proofs. And this allows to develop blockchains on top of it. It's very easy to develop chains on top of sets, but not the other way around. This is also, by the way, a basic principle in mathematics. With sets, you can define lists and everything else on top of it. So that's the main difference. It's a set of claims. Blockchains now can be defined. Blockchains are just applications on top of the set. And now another interesting aspect is what counts as a proof for a claim. And can programs or program executions also be claims? And the answer is yes, because program executions, because of the K framework, can be reduced to mathematical proofs. And once you have a mathematical proof, the fact that you prove, for example, the program execution, becomes a claim. And the proof, mathematical proof, becomes the proof of the claim. Now you can settle that claim, which happens to be a computation. So essentially, any computation with any program in any programming language becomes a claim, which comes with a proof, which is settled through the pi-squared technology. And the pi-squared comes actually from proof of proof, because there is one more step at the end where we generate a zero-knowledge proof, a cryptographic proof from the mathematical proof. Okay, so the claim is true because it has a mathematical proof, and that mathematical proof is checked with a proof checker that generates a cryptographic proof from it. And now you have a succinct cryptographic proof that the claim is true. So now you can settle it. So you see, there are some fundamental differences from how blockchains work. But what's important to realize is that blockchains can be implemented on top of this infrastructure. So pi-squared is a more fundamental infrastructure than blockchains.
Yeah, that's absolutely fascinating. You recently launched the VSL DevNet. What is it, and how can developers get involved? And also, why is it significant for the broader ecosystem?
So VSL abbreviates Verifiable Settlement Layer, which is basically what I told you already, is this set of claims that can be verified and settled. And developers can get involved going to pi2.network, our website, /devnet, and then follow instructions from there. And play with the different applications that we have, like blockchain mirroring, bridging, and AI agents. Essentially, everything that happens on Ethereum is mirrored on our DevNet. So you can see all the transactions, all the blocks on Ethereum reflected as claims on the VSL network. And now you can write programs. Now sky is the limit because you have access to what happens on every blockchain. And we also have an application using AI agents where the AI agents can settle their inference as a claim as well. So an AI agent claims something, that he did some inference from you, that, I don't know, this picture is a fish, let's say, a goldfish. And then that is settled because it has a proof by the AI agent that that is true. But what's interesting, and I think the most fascinating part of it, is that all this can be connected. And now you can programmatically have access to Ethereum, to Solana, to Bitcoin, to an AI agent, to any application, a game, for example, that decides to settle its scores on the same network. So everything is connected to everything else. And you mentioned fragmentation. Actually, we don't like fragmentation at all. We eliminated the TVL word from our vocabulary. We call it TVU, which is total value unlocked. Because essentially all the applications that get connected through our network unlock their liquidity to all the other applications. So TVU instead of TVL.
Yeah, awesome. I mean that is fascinating, and for the developers that are tuned in, definitely go and check that out. Speaking of developers, one of the steepest barriers in Web3 is, of course, the developer learning curve. How is Pi Squared sort of addressing this and lowering the entry point?
On several different dimensions, but probably the simplest to understand, even if you're not a developer, is that you can now program in any programming language that you are familiar with. I know very strong programming languages, very strong programming language developers. I'm a professor of computer science at the University of Illinois, Urbana-Champaign. I teach programming languages. I've been teaching programming languages for more than 20 years. So there are amazing programming languages out there. And for some reason, the programming languages that were chosen by the Web3 community, like Solidity or the Ethereum virtual machine, these are very, very bad languages, badly designed languages. If you're a programming language person, you don't want to learn these languages. Say, this is crap. I'm sorry, but these are bad languages. Yet, that's what you have to learn if you want to get into Web3 as a developer. So now you can use Java, you can use Python, you can use Rust, you can use any programming languages that you're already familiar with. So that's one dimension. Another dimension, which is also important, is that the actual programs are not going to be executed on chain. Actually, there is no chain, we call it on set. So why? Because they're executed offline, offset, and you get a proof of the execution. And now you can settle the computation on set without having to redo the computation. So this saves resources, saves energy, saves time, saves nerves, saves updates of the network, because you don't need to update the network each time the programming language changes. So all these together will make a better developer experience on set.
Amazing. I'm keen to get some rapid sort of fire questions out there on your industry takes.
All right.
What's your take on the proliferation of layer 2s in the market today? Do you feel like we're solving scalability or just complicating the stack?
Good question. And also I have a strong personal opinion about this, so it's right on the target. So first of all, I think layer 2s are necessary right now, but only because the layer 1s are not good enough.
Yeah.
That's why we need layer 2s. Scalability, speed, and cost, and so on. With the Pi Squared network, with a set, there will be no need for layer 2s. Or let's put it differently, layer 1s, layer 2s, layer 3s, they will all live together. Because, as I told you, chains can be implemented as applications on top of the set. So Ethereum, for example, can be one account on set with a particular program that takes you from one state to another. That's what programs do. I don't even know why they are called chains, because you go from one state to another anyway when you execute the program. But now each application will be its own chain, its own app chain on set. So now there is no need for a layer 2 on top of a layer 1 that is implemented on set. Why go on top of that when I can do another account and be another chain? Right. So the total order that blockchains enforce is very hard to achieve. So there is a very complex theory of distributed systems with concepts like strong consistency that need to be enforced, and those are not scalable by theory. They're not scalable even in theory. So in practice, we see what we see in blockchains today. They are slow. But with set, there is nobody waiting in line for nobody else, right? So for example, if two agents want to settle their states, why should they stay in line? Why should one go first and the other after, or the other way around? Why should the sequencer decide which one goes first, which one goes second, when they are completely unrelated? So yeah, so I believe that layer 2s are needed now because of layer 1s, but they will not be needed in the future.
Amazing. Secondly, can you achieve, I'll start that again. Can you achieve true interoperability without relying on bridges? What's your philosophy on this?
So I believe that actually we're already seeing it happening on set already, that each application can be in some sense its own bridge. Each application can have, if an application wants to interact with Ethereum Solana base, let's say, then the application will have a smart contract on each of these and they will maintain their own liquidity, but they don't have to do it the traditional way through bridges, because we already mirror these blockchains on set. So there is an account on set that corresponds to Ethereum, an account that corresponds to Solana, an account that corresponds to Base. And the application only uses these accounts because these accounts mirror very faithfully exactly what happens on the corresponding blockchains. So the application only needs to do transfers or whatever it does with the liquidity or tokens, which may not necessarily be money-based. They can transfer those tokens on set, and that is mirrored on the blockchain as well. It's a bit like an omni-chain philosophy, where you have one view of the entire world, but because some accounts are connected to different blockchains, then those are mirrored on the blockchains as well. So basically, I think that once you have this infrastructure in place and working smoothly, you don't need bridges as we know them.
Mm-hmm. Yeah, amazing. Last of the quickfire questions. AI is obviously becoming more and more integrated with blockchain, particularly in the form of AI agents.
Yes.
Where do you see this convergence heading?
So first of all, I think AI agents will proliferate. We'll have lots of AI agents working for us, hopefully. A few of them for each of us. A few of them for each of us. But I have a pretty strong opinion here that blockchains are not needed for AI agents. All AI agents need from blockchains is payments and settlement, verifiable settlement, right? You need to verify what your agent did. You want to make sure that the agent doesn't do things that are not verifiable. You want your agent to be able to pay other agents. You want your agent to pay you or you to pay your agent, and so on and so forth. So payments and settlement, these are absolutely necessary. However, you do not need a blockchain for this. And currently, almost all the AI agentic companies that integrate with blockchains, they pay the price of blockchains, meaning scalability, for they are slow, essentially, and high cost of transactions. They pay this without needing, actually, the blockchains. They only need payments and settlement. And both of these can be done without blockchains. Actually, this is one of our thrusts of research and engineering in our company, to bring AI agents to set.
Yeah, absolutely. Amazing. Zooming out, what's your broader vision for the future of Web3? Where is this space heading over the next sort of 5 to 10 years, do you think?
So, first of all, I think Web3 is here to stay. We really want to own our own assets and to be in full control who accesses them. So I firmly believe in Web3. What I don't necessarily fully concur with is that blockchains are the answer to the Web3 quest. I think blockchains are an amazing technology that definitely take us a long way in the Web3 belief and revolution, but they do a lot more than we need, and we pay the price for that. If everybody wants to do something in the digital world in the same second, right? And maybe not us, but our agents, AI agents will do for us soon, right? That would be like 10 billion in a few years, right? Transactions per second. Blockchains cannot support that. Even if they get to 100,000 TPS, they will still not be able to support that. We definitely need another technology. And we learned a lot from blockchains. We basically learned that Web3 is possible and is needed, and we want it, really. But like with everything else, right, technology evolves. Blockchains made a very important point. And I think probably Bitcoin is here to stay for longer. I think many other blockchains probably will evolve into something else over the next years.
Yeah, absolutely. You know, when you sort of said that, then it was like my mind was just blowing up, thinking, "Oh my god, actually, where could this go in the next 5 to 10 years? It could be insane, more than we can, more than we even know what to do with the tech. That's for sure." Finally, Grigore, what's next for Pi Squared? You know, in the months ahead, are there any milestones or launches that we should keep an eye out for?
So the DevNet is already there. The testnet will be launched in about 4 or 5 months, definitely before the end of the year, 25. And then the mainnet, which will be spring, early summer 26. So in 1 year from now, we should have the Pi Square decentralized network, the set, in full operation. So these two, short term, within 1 year, the mainnet. That's what we should keep an eye on. Then applications, lots of applications on top of it.
Hopefully so. Amazing stuff. Thank you, Grigore, so much for coming on. This has been, you know, a really good episode for me in particular. I've been following Pi Squared for a little while now, and you know, it's clear that you're building something foundational for the future of Web3. So I'm excited to follow on the journey as well. You know, obviously a framework rooted in formal verification, modularity, and real interoperability. So if you're a developer or, you know, project looking for reliable, scalable infrastructure, then keep an eye out for what Pi Squared is doing. Grigore, once again, thank you so much for joining us on the podcast. I really appreciate it.
Thank you for having me, Aaron.
No, pleasure. And for those listening in, don't forget to like, share, and subscribe to the Web3 Insights for more fantastic episodes like this. We'll see you next time.